Hello, can everyone hear me? I'm going to be learning C++ again. Last stream, I used learncpp.com. This stream, I'm going to be using the same website, but I'm going to be saving the pages as PDFs and reading from those because the author allows it, or at least one of the authors, I think. So let me just change to full screen. Okay, so last stream I did this introduction to objects and variables. I was confused because I only know about objects in terms of classes and objects, like an instantiation of a class, but over here they're defining it as a region of storage that's reserved. Let me see my notes. I did 1.4 as well, but I'm going to be rereading it this stream. Main memory. Yeah. An object represents a region of storage, typically RAM or a CPU register, that can hold a value. Uh, and then assignment copies. Okay. Default initialization. From this onwards, I think I will read it. All right. So I saved them in PDFs, and I'm going to be reading them from PDFs instead. Okay. So variable assignment. After a variable has been defined, you can give it a value in a separate statement using the assign operator. This process is called assignment, and the equal operator is called the assignment operator. So integer width and then the assignment. So this is the definition. This is the assignment. I always thought this was declaration, but they said that they will define the difference later. By default, assignment copies the value on the right hand side to the variable on the left hand side. This is called copy assignment. Yeah, I wrote it here. Can I like whenever I copy and paste, the width is like same? Can I somehow adjust the default width? Don't think so. So define a variable here, assign it here, print it here, and then a new assignment, and then print it here. When this program runs, execution begins at the top of the main, so from here, and proceeds sequentially. First, memory for variable width is allocated. We then assign width to we then assign width the value 5. When we output the value of width, it prints 5 to the console. So over here it prints 5, and then after that it prints 7. When we then assign value 7 to width, any prior value, in this case 5, is overwritten. Thus, when we output width again, this time it prints 7. One downside of assignment is that assigning a value to a just defined object requires two statements, so one to define the variable and other to assign the value. These two steps can be combined. When an object is defined, you can optionally provide an initial value for the object. This process of specifying an initial value for an object is called initialization. I think I can copy this, right? Yeah. Why is this on the next line? Uh, okay, the example is getting blocked by the ad. I'm doing this the first time in stream. I'll just need to know what mistakes I've done so I don't repeat it next time. Different forms of initialization. Unlike assignment, initialization is surprisingly complex. So we'll present a simplified view here to get started. There are 5 common forms of initialization in C++. Default, copy, direct, direct list, value initialization. You may see the above forms written with different spacing. Whether you use extra spaces for readability or not is a matter of personal preference. As of C++, copy initialization, direct initialization, and direct list initialization behave identically in most cases. When no initializer is provided, such as for variable a above, okay, this is called default initialization. Okay, when no initializer is provided, this is called default initialization. Right, this. In many cases, default initialization performs no initialization and leaves the variable with an indeterminate value, a value that is not predictable, sometimes called a garbage value. I think I should have copied this as well. When an initial value is provided after an equal sign, this is called copy initialization. This form of initialization was inherited from the C language. How do I define the default width? Because I want the boxes to be large. Mm. Much like copy assignment, this copies the value on the right hand side of the equals into the variable created on the left hand side. When an initial value is provided inside parentheses, this is called direct initialization. Direct initialization was initially introduced to allow for more efficient initialization of complex objects. Just like copy initialization, direct initialization has fallen out of favor in modern C++, largely due to being superseded by direct list initialization. Okay, however, direct list initialization has a few quirks of its own, and so direct initialization is once again finding use in certain cases. Okay, so list initialization would be these two. No, wait. This is a direct list, this is copy list. The modern way to initialize objects in C++ is to form an initialization that makes use of curly braces. This is called list initialization or uniform initialization or brace initialization. Copy initialization can be hard to differentiate from copy assignment because both use the equal operator, the not equal assignment operator. And direct initialization can be hard to differentiate from function related operations. One of the primary benefits of list initialization for new C++ programmers is that narrowing conversions are disallowed. This means if you try to list initialize a variable using a value that the variable cannot safely hold, the compiler is required to produce a diagnostic. For example, this will cause a compile error. This compiles, this compiles. On line 7 of the above program, we are using a value with a fractional component to list initialize an integer variable. Because this is a narrowing conversion, the compiler is required to generate a diagnostic in such cases. Because on both of these cases, the fractional part goes away and it changes to type int. Okay. When a variable is initialized in using an empty set of braces, a special form of list initialization called value initialization takes place. In most cases, value initialization will implicitly initialize the variable to 0. In cases where zeroing occurs, this is called zero initialization. And then this is the last type, right? Yeah, this is the last type. Um, Initialize your variables upon creation. You may eventually find cases where you want to ignore this advice for a specific reason, and that's okay, as long as the choice is made deliberately. So this is a best practice. An instantiated object is sometimes called an instance. Most often this term is applied to a class type object. To class type objects. Okay, you can initialize multiple variables defined on the same line. So these are allowed. I think this is not allowed. Maybe we can do A, B with the same value. Modern compilers will typically generate warnings if a variable is initialized but not used. And if treat warnings as errors is enabled, these warnings will be promoted to errors and cause the compilation to fail. There are easy ways to fix this. If a variable really is unused and you don't need it, then the easiest option is to remove the definition of X or comment it out. Another option is to simply use the variable somewhere. Uh, in most cases, neither of the above options are desirable. Consider the case where we have a set of math physics values that we use in many different programs. Okay, and then you can use the maybe use attribute so the compiler doesn't complain. Maybe unused. Okay, so hold on. I will go to the next lesson. I have it in PDF. Okay, so 1.5 Introduction to IO Streams. In this lesson, we will talk more about stdc out, which we used in our Hello World program. The output library, IO library, is part of the C++ standard library that deals with basic input output. We will use the functionality in this library to get input from the keyboard and output data to the console. The IO part of the IO stream stands for input output. To use the functionality defined within the IO stream library, we need to include the IO stream header. at the top of any code file that uses content defined in IOStream, like so. Okay, so this is the library, and then we can use the functionality here. The IOStream library contains a few predefined variables for us to use. One of the most useful is stdcout, which allows us to send data to the console to be printed as text. Cout stands for character output. Okay, so this prints hello world to the console. This prints 4. This prints 4. Okay. To print more than one thing on the same line, the insertion operator, okay, that's what it's called, can be used multiple insertion operator, okay, that's what it's called, can be used multiple times. Yeah, I need to check my stream because it says disconnected. Hold on. Hold on. keep keep saying disconnected. Okay, anyways, I'll just see what I can do. Okay, using std and n to output a new line. What would you expect? Okay, I just ran the program. X is equal to 5. Even the syntax highlighting is not working. I don't know why this is the case. Also, yeah, they added a space here. Okay. Um, what would you expect this program to build? So hi, and then my name is Alex. You might be surprised at the result. Well, I mean, yeah, I expected it. So we can add a new line in an OS specific character or sequence of character that moves the cursor to the start of what? Well, to the start of the new line. So std and and L will move the cursor to the next line. In the above program, the second std and L isn't technically necessary since the program ends immediately afterwards. However, it serves a useful purpose. First, it helps us indicate that the end of the output is a complete thought as opposed to a partial output that is completed somewhere later in the code. In this sense, it functions similarly to a period in standard English. Second, it positions the cursor on the next line so that if we later add additional lines of output, uh, example, have the program say bye, those lines will appear where we expect rather than appended to the prior line of the output. Third, after running an executable from the command line, some operating systems do not output a new line before showing the command prompt again. If our program does not end with the cursor on a new line, the command prompt may appear appended to the prior line of the output rather than at the start of the new line, rather than at the start of a new line as the user would expect. std cout is buffered. Let me check the status here. I don't know why it's not loading properly. If I close this, like it did load, but it's not colored properly. Consider a roller coaster ride at your favorite amusement park. Passengers show up and get in line. Periodically, a train arrives and boards passengers up to a maximum capacity of the train. When the train is full or well enough time has passed, the train departs with a bunch of passengers and the ride commences. Any passengers unable to board the current train wait for the next one. This analogy is similar to how output sent to std is typically processed in C++. Statements in our program request that output be sent to the console. However, that output is typically not sent to the console immediately. Instead, the requested output gets in a line and is stored in a region of memory set aside to collect such requests, called a buffer. Periodically, the buffer is flushed, meaning all of the data collected in the buffer is transferred to its destination, in this case, the console. This also means that if your program crashes, aborts, or is paused for debugging purposes, the buffer is flushed, or in uh, any output still waiting in the buffer will not be displayed. The opposite of buffered output is unbuffered output. With unbuffered output, each individual output request is sent directly to the output device. Writing data to the buffer is typically fast, whereas transferring a bunch of data to an output device is comparatively slow. Buffering can significantly increase performance by batching multiple output requests together to minimize the number of times output has to be sent to the output device. Okay, so unbuffered output, the content is directly sent to the console. Using std inline is often efficient as it actually does two jobs. It outputs a new line and it flushes the buffer, which is slow. If we output multiple, wait, what do you mean it flushes the buffer? Okay, it empties the buffer, right? If we output multiple lines of text with std and l, we get multiple flushes, which is slow and probably unnecessary. When outputting text to the console, we typically don't need to explicitly flush the buffer ourselves. C++'s output system is designed to self-flush periodically and is both simpler and more efficient to let it flush itself. To output a new line without flushing the output buffer, uh, we use \n inside either single or double quotes, which is a special symbol that the compiler interprets as a new line character. Okay, so \n, and that's all, folks. \n. Okay, I don't think you can read this, but it creates a new line. When it's printed to the console, this is interpreted as a new line. So over here, if I do \n, then I run it. I'm running the release version, and it's still this slow. Yeah, x is equal to, and then new line 5. I don't know if you guys can see it. X is equal to new line 5. In C++, we use single quotes to represent single characters and double quotes to represent text. Even though \n is represented in source code as two symbols, it is treated by the compiler as a single line feed character, and thus is conventionally single quoted. Okay. Um, we believe it's fine to use or even prefer double quoted in standard output statements. This has two primary benefits. It's simpler to double quote all outputted text rather than having to determine what should be single quoted and double quoted. More importantly, it helps avoid inadvertent multiple literals. We cover multi-character literal and some of the unexpected output they cause in future lesson. Okay, so the best practice is to prefer \n over std. So what's the point of having std and l? Isn't this useless? So now stdcin. stdcin is another predefined variable in the IO stream, whereas stdcout prints data to the console. stdcin reads input from the keyboard. We typically use the extraction operator to put the input data in a variable. So stdc in, get the data from the user and put it in X. Let's just copy all of this. How do you auto format? Enter a number 3 and you entered 3. Okay, what if I do this? Okay. Just like it is possible to output more than one bit of text in a single line, it is also possible to input more than one value on a single line. Get two numbers and store it. Wait, what's happening here? What is this profile 1 and profile 2? So if I do this, yeah, I don't know. What is this? I don't know what this does. So if I type 1, 2, does this. If I run this again, okay. So it needs to be separated by space, and that will be like two different things. Uh, there's some debate over whether it's necessary to initialize a variable immediately before you give it a user provided value via another source, since the user provided value will just override the initial value. In line with our previous recommendation that variables should always be initialized, best practice is to initialize the variables first. In a prior section, we noted that outputting data is actually a two-stage process. The data from each output request is added to the end of an output buffer. Later, data from the front of the output buffer is flushed to the output device. So this is called first in, first out. Similarly, inputting data is also a two-stage process. The individual characters you entered are input as input are added to the end of an input buffer. The enter key is pressed. The enter key pressed to submit the data is also stored as a new line character. The extraction operator removes character from the front of the input buffer and converts them into a value that is assigned to the associated variable. This variable can then be used in subsequent statements. Also, each line of the input data in the input buffer is terminated by a new line character. So the new line is also sent in. Okay, this program inputs to two variables x and y. We will run this program twice. Run one when when this line is encountered, the program will wait for input, enter the value 4. The input for new line goes into the input buffer. The value 4 is extracted to variable x. When stdcin to y is encountered, the program will again wait for input, enter the value 5. The input 5 new line goes into the input buffer and the value 5 is extracted to the variable y. Finally, the program will print you entered 4 and 5. Okay, run 2. When this line is encountered, the program will wait for input, enter 4 space 5. The input 4 space 5 new line goes into the input buffer, but only 4 is extracted to variable x. Oh, because there's a separation by the space. It's space separated. When this stdc in into y is encountered, the program will not wait for input. Instead, the 5 that is still in the input buffer is extracted to variable y. The program then prints you entered 4 and 5. Note that in run 2, the program didn't wait for the user to enter additional input when extracting to variable y because there was already prior input in the input buffer that could be used. I don't know why it's not colored. So this space this, and does it say enter 2 number? Yeah. So it does this immediately. Otherwise, we would input x and then press enter, and then we would have to input y separately. So normally it's expected to do this and then this. Okay, I understand. The basic extraction process. Here's a simplified view of how the extraction operator works for input. If stdcin is not in a good state, the prior extraction failed and stdcin has not yet been cleared, no extraction is attempted and the extraction process aborts immediately. Leading whitespace characters, spaces, tabs, and new line at the front of the buffer are discarded from the input buffer. This will discard an extracted new line character remaining from a prior line of input. If the input buffer is now empty, uh, the extraction operator will wait for the user to enter more data. Any leading white space is discarded from the entered data. The extraction operator then extracts as many consecutive characters as it can until it encounters either a new line or a character that is not valid for the variable being extracted to. Okay. Given the following snippet, here's what happens in a three different input case. If the user types 5a and enter 5a, new line will be added to the buffer, 5 will be extracted, converted to an integer and assigned to the variable x. A will be left in the input buffer for the next extraction. Is that because A is invalid? If the user types P and enter, P would be added to the buffer because P is not a valid integer. No characters can be extracted. So this is an extraction failure. Variable x will not would be set to 0, and future extractions will fail until the input stream is cleared. If stdcin is not in a good state due to prior failed extractions, nothing happens here. Okay, so what happens if I do this? So if I type an integer and then letter, then this. Oh, it says 0. Wait, hold on. 0. So what if I do a, a. So I have a middle variable. As long as there's an invalid integer, it would always give 0. Is that the case? Yeah. What if I do character? Is it character? This is correct, right? I don't know why it's not highlighted. There's no character data type. What about string? Oh, it's char, like that. Now it's working. So C in and C out always go on the left hand side of the operator. Okay. Consider the following program that we used above. Can't even clearly read it. The program expects you to enter an integer value as the variable x. Hold on, maybe I can copy it. return. Why is it like this? So enter a number. Okay, this is being displayed to the console, and then X, then goes into X. Okay. I can see the answer. So a letter such as H, 0 is always printed. Hold on. Hmm. A number with a fractional part 3.2. Try numbers with a fractional part less than 0.5 and greater than 0.5. I think the fractional part gets uh, it gets rid of the fractional part. I think it depends on the type of assignment. Since direct lesson assignment doesn't allow narrow conversion, then it may give an error, I think. Let's see. See declaration of main. What's written? Oh, 0. So if I do 4.5, you entered 4. Okay, so what goes into the buffer is like, wait, I thought like when you assign integer to this, hold on, let's see, int y 4.5 and then y. Let's do this. How do I disable like auto formatting? Why? Whoops. Yeah. Yeah. So narrowing conversion is not allowed. So why is it? Hold on. Would this be allowed? I think direct. I think it only gives an error when there's a direct assignment. Only during initialization. Let's see. Yeah, it gives an error here as well. So why does it work with the input buffer? Shouldn't it give an error because maybe I think it's seeing the character. It so if I do 4.5, it reads this 4 character and then 0.5 remains in the input buffer. That's what I think is happening. The fractional part is dropped. Given the number 3.2, the 3 gets extracted, but dot is an invalid character, so the extraction stops here. Point 2 remains for future extraction attempts. Yeah, that's what I suspected happening. If you're wondering why this isn't a disallowed narrowing conversions are only allowed during list initializations, which happens on line 6. Small negative number like -3. A minus sign at the beginning of a number is acceptable, so it is extracted. A word such as hello, again there's an error, not extracted, result is 0. A really big number, I think the first few digits are entered. X can only hold numbers up to a certain size. If you enter a value larger than the largest number X can hold, it will set it will be set to the largest number that X can hold. Okay, let's see. If I do X and Y, Y. So this. Or why would it the rest of the numbers go to Y? Because the rest of the input is still a buffer, right? Or do these get skipped? Let's see. Nope. I don't know what's happening. A small number followed by some letters such as 1, 2, 3, ABC. 1, 2, 3 is extracted, then the remaining characters are left for later extraction. Plus 5. 5 is printed. The leading white space is skipped. 3 spaces followed by a plus sign and a 5. Plus is a valid symbol at the start of a number. 5b6, 5 is printed. Okay, I should do one more lesson and then I will end the stream. Okay, Alt F. Unlike some programming languages, C and C++ does not automatically initialize most variables to a given value, such as 0. When a variable that is not initialized is given a memory address to use to store data, the default value of that variable is whatever value happens to already be in that memory address. A variable that has not been given a known value is called an uninitialized variable. Many readers expect the terms initialized and uninitialized to be strict opposites, but they aren't quite. In common language, initialized means the object was provided with an initial value at the point of definition. Uninitialized means that the object has not been given a known value yet. Okay. Assignment, the object is given a value beyond the point of definition. Okay. As an aside, this lack of initialization is a performance optimization inherited from C, back when computers were slow. Imagine a case where you were going to read in 100,000 values from a file. In such case, you might create 100,000 variables, then fill them up with data from the file. If C++ initialized all of those variables with default values upon creation, this would result in 100,000 initializations, which would be slow and for little benefit. Using the values of uninitialized variables can lead to unexpected results. Consider the following short program. In this case, the computer will assign some unused memory to X. It will then send the value residing in that memory location to stdc out. Okay, let's see what happens if I do this. Whoops. It's 0. Would it always be 0? Okay. Some compilers, such as Visual Studio, will initialize the contents of memory to presence to some preset value when you're using a debug build configuration. This will not happen when using a release build configuration. Therefore, if you want to run the above program yourself, make sure you're using a release build configuration. Yeah. What's the difference between these two? Local Windows debugger and this start without debugger. If I want to debug, what I select from here? Okay. Don't worry about what ampersand is for now. You're just using it to take the compile into thinking variable x is used. X do nothing. Okay. Undefined behavior. Using the value from an uninitialized variable is our first example of undefined behavior. Undefined behavior, often abbreviated as UB, is a result of executing code whose behavior is not well defined by the C++ language. Wait, I just realized I wasn't making any notes. Okay, so 1.6. Oops. Undefined behavior is the result of executing code whose behavior is not well defined by the C++ language. Uh, this Okay. Code implementing undefined behavior may exhibit any of the following symptoms. Yeah. Implementation defined behavior were an unspecified behavior. A specific compiler and the associated standard library it comes with are called implementations, as these are what actually implements the C++ language. In some cases, the C++ language standard allows the implementation to determine how some aspects of the language will behave, so that the compiler can choose a behavior that is efficient for the given platform. Behavior that is defined by the implementation is called implementation defined behavior. Implementation defined behavior must be documented and consistent for a given implementation. Okay, I will copy this. Called an implementation. Here's a sample example of implementation defined behavior. Prints how many bytes of memory at of how many bytes of memory an int value takes. On most platforms, this will produce 2, but on others it may produce, on most platforms this will produce 4, but on others it may produce 2. Unspecified behavior is almost identical to implementation defined behavior in that the behavior is left up to the implementation to define, but the implementation is not required to document the behavior. Okay. So unspecified is like implementation defined behavior, except that it is not documented. We generally want to avoid implementation defined and unspecified behavior, as it means a program may not work as expected if compiled on a different compiler. What is an uninitialized variable? How would you avoid using them? I think just by initializing it. Uh, should you avoid? Oh, why should you avoid using them? Because it will have unexpected results. Using a value stored in an uninitialized variable will result in an undefined behavior. What is undefined behavior? What can happen if you do something that exhibits undefined behavior? Undefined behavior is the result of executing code whose behavior is not well defined by the language. The result can be almost anything. Okay. Uh, hold on. I think I will end the stream here. But let me see what notes did I miss. So this. this std out. Let's see what else. And the operator. Does the insertion operator, like even if you don't use std out, will it concatenate strings? And then the difference between new line and backslash n. And these nodes are not useful. I think it would depend if I'm getting back to them. Std out when a variable is initialized. I should just do bullet points. That deals with output. I think it's like this. Yeah. Uh, now I write this to output the compiler, and I want to make sure that NL is slow. Uh, Also, what else? I need to write about CN. And we typically think that was the main point. Inputting data is a two-stage process. Uh, Okay, inputting data is a two-stage process. Okay, is there any list point here? Nope, there isn't. So, and is there anything? Let's see. I think those were the main points I wanted to add. Yeah, well, I guess I will end the stream here, and I'll see you guys, I think, next time. Maybe tomorrow, hopefully. Anyway, see you whenever.